Industry 5.0 marks a shift from full automation to human machine collaboration. And at its core are cobots, or robots designed to work alongside people. As adoption grows, the market is expanding at nearly 30% annually. To hear more about this, we have Nigel Lee from Lenovo and Iswaran Subramanian from Deloitte Asia Pacific. Now let's start with the landscape. Which sectors are leading the charge in adopting Industry 5.0?
There's no particular one, but I think across the board, we are seeing a huge growth, compounded annual growth of 31%. And this will continue to grow until 2030. And in APAC, the 5.0, in the collaboration with not only the 4.0, but addition the human, the robots, and sustainability, that will definitely grow. We are seeing that the manufacturing is pivoting itself to Industry 5.0. This is to really meet the needs of increasing productivity and efficiency. As part of Lenovo, I think we are really big in the supply chain. Actually, in fact, just yesterday we were given the 8th position at Gartner as the world supply chain, I would say, position. And our factories are all has been converting to a smart factory under the Industrial 5.0. This will definitely help our company to be more efficient, to be more productive, and also to pivot towards the supply chain where we've seen during the COVID days that we are able to switch from factory to factory. And this is done through the Industry 5.0.
Fastest one obviously is automotive, driven by the drivers being customization and volume flexibility. The second one is electronics as well as semiconductor manufacturing, primarily driven by the need for precision critical manufacturing. The third, which is aerospace and defense, predominantly driven by safety critical engineering being the big driver. The fourth one is areas where there is significant human involvement, which includes apparel and textiles, as well as leather and footwear. And the last one is where there is a lot of hyper-personalization coming in, which is in the high-end luxury goods scenario.
Now, even with these sectors leading, what has been the biggest challenge when it comes to scaling cobot deployment?
There are a couple of challenges, I think, because cobots work hand in hand with AI, and AI has been the big thing in the last a year and a half or two. Is really having the executive or the CEO of companies or CIO of companies understand what is really AI. Do they really know what is AI, and how do AI work with cobots? That's the first challenge. The second challenge is definitely, do they have the data, to really use the data to make the cobots to work for them, to produce the efficiency and productivity. So that is the second challenge. And the last time, and it's not going to be not be the least of the last, definitely cybersecurity. I think in today's environment, cybersecurity becomes a very big issue because any system can be hacked as long as they're in the cloud.
How can we have cobots operate safely alongside humans without causing harm remains the foundational concern for people. So that's the first one. The second one is while cobots would comply with basic safety standards, they often require additional sensors, environment mapping, and lot of ongoing monitoring to ensure safety in a very dynamic environment. So therefore, real world deployment has a lot of safety elements attached to it. So safety and trust becomes the first big dimension. The second one is integration with legacy systems. See, we are not starting afresh. Most organizations have a lot of legacy systems, including PLCs, CNCs, mainstream enterprise application systems like ERPs, etc. Earlier, since there are a lot of legacy, they've not been built for cobot communication. So therefore, there's a bit of a disconnect between the intelligent cobots and some of the hard infrastructure that we have or the legacy infrastructure that we have. Therefore, integration with legacy systems typically requires modern middleware, a lot of field-bus protocol compatibility. Those are dimensions that become very relevant. And incidentally, cobots also, a lot of them operate in silos. Therefore, they limit the requirements in terms of real-time data feed into broader systems. So to that extent, I think the second big area would be integrations with legacy systems. The third one is the economies of scale that we have always discussed even in the Industry 4.0 scenario, which is cost versus return on invested capital. Therefore, smaller manufacturers would always have a challenge compared to much larger ones where the entire ecosystem is scalable and repeatable. I think the smaller ones would have a challenge. And finally, the fourth one I would say is programming complexity. Cobots are obviously much more easier to program than traditional robots, but scaling across diverse multiple tasks requires skilled operators. Therefore, I think a lack of standardized programming frameworks across vendors is therefore adding to the complexity given the requirement of skilled workforce. And those are the four big things. Obviously, goes without saying that there is a big cultural shift which is required, because there'll always be gaps that would come in from a skill perspective as well as workforce resistance.
It's also worth raising that there are concerns surrounding use of AI and robots. So with that, what safety protocols are needed for human cobot collaboration when it comes to manufacturing?
I would say it's protocol. I think basically, how can cobots help a manufacturing or company? Take for example, in areas of dangerous of human going to a dangerous area, actually, fact, the cobots can go in, without having to put a PPE or oxygen tank to go to do an inspection. For example, a tunnel or a oil tanker where humans are lowered into a tanker to do inspection. All right. So robots or cobots can be used in those areas, and they can stay in there at a prolonged time as compared to humans. So I think those safety aspects is actually like helping humans. You don't have to put a physical human into those areas, and cobot can be able to assist that. I think the other aspect is definitely the safety protocols of AI. I think that is something, because we know that AI cobots need AI, and we need to make sure that the governance and compliance of AI is actually built into those cobots.
I think cobots must be equipped with a lot of multimodal sensors, including vision systems, etc., which can actually have identify human presence real time and therefore avoid collision. So a lot of safety requirements from a collision perspective becomes very relevant. The second one is also therefore in line with that advanced sensing. They must be able to detect human presence much in advance, and therefore to that extent I think advanced sensing together with collision avoidance becomes a big area. Together with that would be the real-time feedback loops. So they must be having real-time closed-loop control systems so that they can continuously monitor aspects like end effector speed, trigger safety actions, so that whenever deviations occur, it can actually ensure that they are continuously monitoring it. The second one is that they should also leverage all the field bus protocols so that they can communicate real time any safety event to the controllers so that actions can be taken pretty quickly. So real time feedback loops become very, very relevant. And with that in context also, therefore, becomes the entire aspect of what we call transparent autonomy. Therefore, they should be able to incorporate the dimensions of AI and the related ML logic so that we are able to really build in the autonomy into it, so that the next time we would be able to really identify why did the robot stop, what happened, and therefore build that back into our safety systems.
Thank you so much for joining us today, Nigel and Iswaran.
Thanks a lot.
Thank you.
Once again, those were Nigel Lee, Country General Manager at Lenovo Singapore, and Iswaran Subramanian, Deloitte Asia Pacific Supply Chain and Network Operations Leader. For more news, visit manufacturing.asia.